All right, and then angle 3 or number 3, it says the measure of angle 1 and 3 is equal to 90 degrees. That was from the given. They gave us that. And then 4, that's a definition of complementary because we got measure of angles involved. So definition of complementary. Okay, and then what do we know now? We got look at all the statements that we have. Go back to the start. We have number 1 that was given, that they form a right angle, and number 2, the result of that was that 1 and 2 are complementary to one another, or they're complementary angles. And then all this work here got us to angle 1 and 3 are complementary. Angle 1 is complement with 2. Angle 1 is also complement with 3. And then 5 says 2 and 3 are complements. Because 2 does not say anything about measurements. If you go back to the front page of your little packet here, and we look at those theorems, they don't have anything in them about measurements. The definitions talk about sums. Some is 90, some is 180. So they talk about the addition of that things. These are the theorems talk about just the names of them, what you're calling them. There's no math involved in it. Even though we know what complement does. In our brains, we want to think, oh, that adds to be 90. But by them forming a right angle, we know that they're complements of one another, and we don't have any measurement involved. So number 2 is a theorem, complement theorem, where number 4 is the definition of complementary angles because there's an addition involved. There's a math problem that got us there. That's the difference. That's a hard difference to differentiate because they do the same things. But one of them involves adding them together to equal 90 to be a complement. The other one says they make a right angle together, not that they add to be 90. Because 2 angles can be complementary and not be inside of a right angle. Like you could have one angle over here and then another angle somewhere off the page over here, and they could add to be 90, be complements of one another, but they may not form a right angle out of that. So that's our picture happens to be that they're on the same, in the same general area, but they could technically could be 2 different pictures, honestly, 2 separate pictures. So 2 and 3 being congruent should be a congruent complements theorem. Remember, the congruent complements theorem is kind of like transitive property for complementary angles, is the way you want to think about. Congruent complements theorem is like transitive property for congruent or for complementary angles. All right, at this step, from here to here, the definition of complementary angles takes care of the measurement and then not saying the measurement. So that definition of complementary angles puts us back into object mode, I guess is the right way to think about it. Through that definition is how we got back. Didn't have to do definition of congruence or anything like that. All right. Number 4, ray BE bisects angle ABD and ray BD bisects angle EBC. And so number 1, obviously we all know that. But what is number 2 should it be? Angle ABE is congruent to angle ABD. Well, what's ray BE? It's bisecting, right? So it's bisecting what? Bisecting an angle. So it's an angle bisector. So what do we have in our page here about angle bisectors? A definition of angle bisector says if you got an angle bisector, it cuts it into two equal parts. So that's a definition of angle bisector. And then number 3 is also in the given. And then EBD is congruent to DBC. Another definition of angle bisector. And then 5 should be, I heard somebody whisper it, transitive. Yes, it's transitive. It's the secret transitive property. So transitive property, because we have 3 things there. We have ABE is congruent to this one. So 1, 2, 2, 3. So 1 and 3 are congruent to one another. That's transitive property. I know that. So straight up transitive on that one. Okay. That one's pretty easy. Maybe that one's a little too easy yet. Let's do one that's harder. Let's go to number 5. All right. Number 5, they don't give us a lot of information here. They give us that RSU is congruent to VST, and they want us to prove that RSV is congruent to UST. So number 1, I'll take care of that one. Now, what does number 2's reason? Yeah, that's the one that lets us talk about the measures of those angles. So number 3 is what? That angle addition postulate? Yeah, because RSU plus USV equals that bigger angle that we're trying to prove about. So that's angle addition. What number 4, VST plus USV is equal to UST. UST is the larger angle there, right? And those other 2 make that one up. So that's another angle addition. Now they're just building the bigger angles, like we did with the segments. We built both of the segments that we're trying to get parts congruent on. And so we're going to have to build those angles too. And then what next? RSU plus US. This would be, I would call this one substitution, because you don't have 3 things involved there. You kind of do, but you're replacing. You've got this line completely here, and you're replacing it with this one. I'm gonna say it's substitution there. I don't think I probably wouldn't count off if you use transitive, but I think it's more of a substitution. And then RSV is equal to so RSU plus USV. So yeah, we substituted here with those 2, and then we know that this is also equal to this, right? So, or this is equal to this is what I'm trying to point at there. This, and that would be transitive, because there are 3 things there. And then the last one is a definition of congruence to get the measurement off of there. So again, it's just like the segment proofs that we did. Anytime you're taking smaller pieces and building a larger angle, or you're looking at a larger angle, like RSV was a larger angle than any of the pieces we had, and UST was the same way. You've got to build those angles out of the smaller ones. So use that angle addition postulate, just like we did with the segment addition postulate on Friday. All right, 6. 1 and 2 are complementary. 3 and 4 are complementary. I really don't know why they took up 2 lines to do the given there. I would be okay with you doing 1 line out of that. They give and they give. All right. And then 3 and 4. Yeah, that's definition of complementary angles. And it's the same thing again here. And then how did they go to 2 is congruent to 3? Vertical angles. Because in the picture, there are vertical angles. We know they're congruent to one another. Number 6, that'd just be a definition of congruence. And then 7. Look at those 2 lines. That'd be transitive property. Be substitution for 8, because what's changing between 7 and 8? The 2 at the measure of angle 2 and the measure of angle 3 right there changed out, so that's substitution. Good job, that's right. And then 10. Yeah, definition. Boom. That was a pretty long one. All right, now we get to so all of those had all of the reasons for the statements for us. We had to fill in the reasons. These mix it up a little bit here, so we're going to get the some statements and some reasons, and we got to come up with the missing parts here. This is more how it'll be on EOC. They'll be a lot like this on EOC. So. Angle 1 and angle 4. I hope they give you one of these on EOC. You just try to give it there. That's all they ask. That'd be nice. Number 2. Yeah, definition of congruence just says, okay, if those are congruent, then this is what happens. And then what goes in the statement for number 3? Perfect. Good job. Supplement theorem, because it says linear pair. If it added them together and got 180, then what is that? Definition of supplementary angles. So if the reason is definition of supplementary angles, then the statement should be something about adding some angles together to equal 180. So we're going to add angle 4 plus the measure of angle 5 equal 180. 180 looks stupid. And then, yeah, measure of angle 1 plus the measure of angle 5 is equal to 180. So that's the substitution that's happening. And then the last reason would be which one? Why definition this time and not supplements theorem? Because they're adding measurements together to get 180. So that's definition of supplementary angles. That wasn't too bad. That was pretty good. All right, let's try number 8 there. Almost done, almost time for practice. Angle 1 and 2 form a linear pair, and then the measure of angle 2 plus the measure of angle 3 is 180 degrees. Please don't miss number 1. And then what do we know about number 2? They form a linear pair. The reason is the supplement theorem. So what does that tell us about angles 1 and 2? Angle 1 and 2 are supplementary. And they tell us in number 3, it's the given. So the only given we haven't used yet is that one, the measure of angle 2 plus the measure of angle 3 equals 180. And then what do we know about, what does that statement give us, Lord? All right, and then what does that tell us in the statement for number 4 based on that definition of supplementary angles? No. That's true, but it doesn't help us get to the punchline. Our punchline is angle 1 is congruent to angle 3. So what does this statement, by definition of supplementary angles, tells us that that angle 2 and angle 3 are supplementary. And then angle 1, since it's supplementary with angle 2, and then angle 2 is supplementary with angle 3, that's kind of like transitive, but it's more specific because it's talking about supplementary angles. So it's the congruent supplements theorem. It's on the front there, the very last one, very bottom one, congruent supplements theorem. It's like transitive property, but it's talking about supplementary angles, so it's a little bit more specific. Congruent supplements theorem. That one's got a little twist to it because of the supplementary, but congruent supplements theorem. So we can spin our way through number 9, another fill in the blank. AB is what to BC? What's that mean? Perpendicular, and then angle 2 and 3 are complementary. So in our picture there, AB and BC, line BC are perpendicular. 2 and 3 are complementary, and we're going to prove that angles 1 and 2 are congruent to one another. So number 1 is obviously given. We all know that. And then where are we getting ABC as a right angle? Yeah, definition of perpendicular. And I'm going to use the abbreviation for perpendicular there instead of writing it out. And then 3 says definition of a right angle is the reason. Yeah, the measure of angle ABC equals 90 degrees. And then number 4 says measure of angle 1 plus the measure of angle 2, or excuse me, measure of angle 3 is equal to the measure of angle ABC. So what is that? Angle addition. They took 2 smaller angles and made the bigger one. So that's angle addition. Technically angle addition postulate. And then measure of angle 1 plus the measure of angle 3 is equal to 90 degrees. Substitution, or I would take transitive on that, either or out of that. So transitive / substitution. One or the other, I don't care which on that one. All right. Definition of complementary angles is number 6. So what does the definition of complementary angles mean? Say. So if the sum of the angles is 90 degrees, then they're complementary angles. So that tells us that angles 1 and 3 are complementary. And what that does is gets us out of measurement mode and into object mode. So we're talking about the angles themselves, not the measures of those angles. And then number 7, they go back and pick up that piece of the given that they did not use. So that's angle 2 and angle 3 are complementary. And then if angle 1 is complementary to angle 3 and angle 2 is also complementary to angle 3, then angles 1 and 2 must be congruent to one another.
May I have your attention, please? If the fire alarm sounds in the next few minutes, please disregard and stay where you are. If the fire alarm sounds, please disregard.
Congruent complements theorem. All right. Questions about what we've been doing? This takes a little bit of practice. It's not necessarily